I want to cover the material which is covered in LO3, Learning Outcome 3, which is all about cryptography. And we discussed cryptography, encryption, decryption. We talk about the aims of cryptography, and we talk about certificates. And this has a lot of information in it. This particular LO is a real target for testing by examiners because it is so deep. Of all of the things that we've done so far, this is the one where your memory will best be tested. So you have to get really used to remembering things, and I thought that these resources might help you remember the core key facts that you have to think about. So let's start from the scratch. Let's start from what we do with encryption. What is cryptography? Cryptography is the process of encryption and decryption. And what do? We take plain text and we disguise it. We make it unreadable, and we call that ciphertext. When plain text has been converted into something unreadable, it is ciphertext. And that's the process called encryption. Now we have to be able to convert that text from ciphertext back to plain text so that it becomes useful again to the reader. So we call that decryption, turning ciphertext into readable plain text. So that's very straightforward. We've covered that quite a lot. So what is encryption? Encryption uses two things, always uses two things, an algorithm and a key. The algorithm is publicly known. People have spent a lot of time developing it in universities, in big companies, in Microsoft and so forth, in Cisco. They spend a lot of time developing algorithms. So the algorithm will work uniquely based on the key that it is given. So that's what must be the two things that you would have in any encryption process. Now, symmetric encryption uses the same key for encryption and decryption, and is commonly used on your computer programs that you use every day. Here's an example of a symmetric encryption process built into a program called WinZip. Now, WinZip is used to compress files into folders to make them easier to transfer from one place to another. And we use these WinZip processes a lot, but few people actually look to see that you can actually encrypt the folder so that it's unreadable unless you know the password. So we can enter the password, and that key will be that password will be used to generate the key. Now you'll see on the bottom right hand corner we've chosen to use AES 256. That's the name of the algorithm that we're going to use. Now we could use AES 128 or the old WinZip standard, but we choose to use AES 256. So what is AES 256? AES is the name of the algorithm, and 256 is the number of bits in its key. There are 256 bits in the key that is used to make the algorithm generate the encrypted ciphertext. The 256 is called the key space, and we can work out the number of possible unique combinations based on the size of the key space. So if you imagine a combination padlock with 4 dials, each has got 0 to 9 on it, very common. Its key space is, because there are 10 on each dial, 10 times 10 times 10 times 10, 10,000. There are 10,000 unique combinations on that padlock. So what does AES 256 use? It has 256 sized bits in the key space, so it's 256 times 255, etc., which works out to be 1.1579 times 10 to the power 77. That is a very large number, and effectively we couldn't use that number of possible combinations to easily discover the key that has been used. So how are keys cracked? They're cracked probably in these two most common methods. Dictionary attacks, where we use patterns of known behaviour of commonly used words, and if they don't work immediately, we go on to database of known words. The databases of known words might be covering the English language, French, Spanish, all those other ones, and given today's computing power, we can check all the language dictionaries really quickly. The alternative is a brute force attack, where we simply exchange characters and symbols and numbers and so forth into every possible combination of the Unicode character set in the key space. So that's a very, very sophisticated technique, and given today's computing power, is increasingly used. So how do we make a strong password if we're going to generate something that's going to give us a really strong key in our encryption process? They've got to be difficult to crack. So if you go to grc.com, which is a Steve Gibson website, he's one of the absolute gurus about encryption and security, And from the Services menu, select Password Haystacks. And I've got an example of what happens here. So here I put in a 16-character password, and it's got 1 uppercase, 7 lowercase, 6 digits, 2 symbols. Not necessarily that shape. I just chose that shape because I was kind of typing random stuff into the box. And you'll see that given this very strong password, given the number of combinations that it must be requiring to be able to be cracked, given a massive cracking array, that's 100 trillion guesses per second, it is unlikely that this could be solved or cracked in less than 1.4100 million centuries. Now, that's known as an intractable problem. It cannot be solved in a realistic timescale. So, here are the most common used passwords based on a 10 million password sample from an application database. And you'll see they are absolutely special. You know, from 1, 2, 3, 4 being probably the weakest, to let me in and princess. Or look at that one, 6 ones in a row. That's really secure, isn't it? But people still use these. People are silly enough to use this type of password and expect to have security based around it. So, symmetric encryption algorithms are of various types. Here are some commonly known ones: data encryption standard DES, triple DES, blowfish, RC4, RC5, RC6, and Advanced Encryption Standard AES. Now, symmetric encryption is used in common everyday tasks, and it would be that way, wouldn't it? Because you're the person who knows what they're doing with the password, and therefore you've got to have ability to recover that, to use that password again when you decrypt. So, recommendations. If you can, where it's offered, use AES 256 because currently it's uncrackable and it's very fast. You should avoid outdated and weak systems such as DES and RC4. So that's just a roundup of the very first part of it, covering what encryption is and some common symmetric encryption standards that we might use.